thanks for clicking. Welcome to another Margulis production. Today we're going to look at take a graphical look at all the derivative relationships that we know. So we know derivative relationships, the first derivative test, and then we know this test for concavity now, where we have things that are two derivatives away from another and how they're related. All right, so let's take a look. Let's summarize everything that we know so far, and then we'll actually take a look at a problem and see what we can do with it. So here's things we already know about derivatives. If f prime is positive, then f is increasing. If f prime is negative, then f is decreasing. All right. If f prime changes from positive to negative, then f has a relative max. All of this, remember we did from the first, this was the first derivative test, right? Okay, it's basically the summarized first derivative test. And then we also learned, or recently learned, about f double prime. If f double prime is positive, then f is concave up. F double prime is negative, f is concave down. If f double prime just changes sign, I don't care, from positive to negative or negative to positive at a point, then x equals c, that point is a point of inflection. This was the test for concavity. And it involved the second derivative. Okay, so we have the test for concavity and the first derivative test. Now we're going to take a look today at how to apply those graphically. All right, so here's a graph. Okay, it's the graph of f prime. So the graph I'm looking at is the graph of f prime of x. Now, the most important things you need to understand about this are, number one, you need to know what graph you're actually looking at to be able to answer the questions. And number two, when you look at a question, you need to know what graph they want information about. Because 9 times out of 10, it's not about the graph you're looking at. All right, you can use the graph you're looking at to get the information, but they're usually never asking you about the actual graph you're looking at. They want you to figure out what they want using the graph you're looking at. Okay, this is the graph of f prime. So letter A asks us on what interval or intervals is f of x increasing. So now here's how I tend to do all these. I tend to make these little sign charts. Okay, so f prime is what's given to me. I want to know when f is increasing. If f is increasing, then what do I know about f prime? Well, I know that f prime would be positive, right? When f prime is positive, f is increasing if I go backward. So the question is, well, this is the graph of f prime. So where is f prime positive? Where is it above the x-axis? From there down to there. So we're looking at x values from -3 to -2. The -3 I'll include because it's positive, but the -2 I will not because it's 0 there. It's not positive. So where is f increasing? From -3 to 2. Reason? Because f prime is positive. When you justify your answer, you're always justifying your answer or explaining your reason, always explaining your reasoning using the graph that's given to you. Okay. All right, letter B. At what x value or values, if any, does f have a relative max? Okay, now I want f to have a relative max. That means f has to go from increasing to decreasing, right? Think about it. Relative max looks like that, increasing to decreasing. But I don't have the graph of f in front of me. I have the graph of f prime. So f prime, for f to be increasing, f prime would have to be positive. For f to be decreasing, f prime would have to be negative. So I am looking on this graph for where f prime is changing from positive to negative. Where is f prime changing from positive above the x-axis to below the x-axis? Right there. So my answer is x equals -2. Why? Because f prime changes from positive to negative. And that's all you have to say. You don't have to go into a 20-minute explanation about that means f is going from increasing to decreasing. That means f has a relative max. You just have to justify your answer using the graph that's given. Okay? All right. Let's try some more. Let's keep going. So this is going to be on the AP exam. There's no doubt about it. Same graph. This is the graph of f prime. Very important. Let's see what they're going to ask me about. On what interval or intervals is f concave down? All right. So now I want f to be concave down. Well, normally, if I'm doing this algebraically and I'm looking for where the graph is concave down, I would go to f double prime. And when f double prime is negative, f would be concave down. But I don't have the graph of f double prime. I have the graph of f prime. So now, if I want f double prime to be negative, what would have to happen to f prime, the one before it? Well, this is a one derivative relationship between these two, right? F double prime back to f prime. They're one derivative away. So when f double prime is negative, that means f prime would have to be decreasing. So I need to know where f prime is decreasing. So f prime is decreasing from -3 to 0, there to there, and then again from 2 over to 4. Oops, from 2. Let's erase that. From 2 over to 4. Reason? Because f prime is decreasing. And that's all you have to say. You don't have to explain this little chart, how you went from, here to there to there, and then how that tells you. Done. That's the graph you're given, f prime. That's how f prime justifies that f is concave down. Okay, next. At what x value or values does, if any, does f have a point of inflection, a pi? So for f to have a pi, that means f has to go from concave up to concave down, or concave down to concave up, which means that on f double prime, if I were doing it algebraically, it would have to change from plus to minus, positive to negative, or negative to positive. But I have f prime. If f double prime is positive, then the one before it is increasing. F double prime is negative, the one before it's decreasing. If f double prime is negative, f prime is decreasing. F double prime positive has to be increasing. So I need to know where f prime is changing from increasing to decreasing or decreasing to increasing. F prime. So what does that mean? I need to know where f prime has a relative max or a relative min. So f prime has a relative min here, x equals 0, and here at x equals 2. So at x equals 0, there's a pi because f prime changes from decreasing to increasing. At x equals 2, the graph is increasing before it, then decreasing after it. There's a pi because f prime changes from increasing to decreasing. And that's my answer. Okay? All right, so you can see what we're doing. We're using in tandem now the first derivative test with the test for concavity and kind of moving all over the place. Okay, next question. On what interval is f double prime positive? So I want f double prime to be positive. Well, I don't have f double prime, I have f prime. F double prime is positive if the one before it is increasing. The derivative before it is increasing. Where's this graph increasing? from there to there, from 0 to 2. Reason? Because f prime is increasing. There's my answer. And that's it. That's how this works. It takes practice, but we are going to practice and we're going to get very good at it. Okay? And that's it. Thanks for clicking.